So let us now look at the very important topic. It's called the parametric form of a circle. So with using this form, I'll be able to create every point on the circle. Just like the parametric form of a line, this is also one of the most powerful ways of representing a circle, and one of the most useful ways, because you'll be able to create any point that you want on the circle. So I know the center of the circle, I know the radius, let the radius be some a. How do I find the equation, right, in the parametric form? That is the question. So if you can look at this general point, so out of all these, what is this pink circle basically? It is a collection of infinite points. I'm picking up one point from that and I'm calling it xy, right? I'm calling it xy. So that clearly means that the x coordinate of this p, so p is this far from the y-axis. So if I drop a perpendicular from here, this will be x units. And what will be the height of this? It will be y, right? So y is the height of that, this particular point p. Coming to the center now, when you come to the center and drop a perpendicular, the center is at a units at h units away from the x-axis. So this distance is your h. This was your x, right? And what is the height of the center? Well, the height of the center is very understandably this k, right? It's k units above. Now, if you look at this triangle, so what I'm assuming is this point P, the line joining the point P from the center is making an angle theta with this horizontal. This is the horizontal. So if you look at this triangle now, let me just name this point as some O. If you look at the triangle POC, then what is cos theta? Cos theta is CO by CP. CO by CP, and CO is nothing but x minus h. That's very visible in the diagram. This is your CO, and that is x minus h, right? You can figure that out yourself. And CP is a. So x minus h is a cos theta. Likewise, what is sin theta in the triangle? Sin theta is nothing but PO by CP. PO is nothing but y minus k by a. CP is a. So y minus k is equal to a sin theta. So I can write x comma y as h plus a cos theta comma k plus a sin theta. This itself is the equation of the circle in the parametric form. Now, why am I telling you that using this equation, I can create every point on this particular circle? That is because if you keep varying theta, I'll keep getting different values for xy, right? Because h is fixed, a is fixed, k is fixed, a is fixed. Theta keeps varying, cos theta and sin theta will keep varying, and I'll keep getting different xy's. What are those xy's? Those xy's are basically different points on the same circle, because this point has some theta, this point will have a different 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 theta. Likewise, your theta can vary from 0 to 2 pi, right? It can vary from 0 to 2 pi. Theta can be equal to 0 and it can go up to 2 pi. So in between this, I'll have infinite values of cos theta and sin theta, and as I keep putting those values, I'll keep getting different xy's. So if I want this point, if I want to point 180 degree opposite to O, I can put theta equal to 180 degree, and I'll get x comma y is equals to h minus a comma k, right? H minus a comma k. Likewise, I can put any value of theta and get that particular point on the circle. So this is what is the parametric form of a circle. It's a very useful form. I hope you remember this, because this is very simple. A cos theta plus x coordinate of center comma y coordinate of center plus a sin theta. This is what you need to remember. And with this, we are done on our discussion with parametric form of a circle. Let's move on to the next topic.